Hello, everyone. Welcome to our afternoon session of DevFest UKI in Ireland 2021. Um, we are going to have three speakers in the session. I apologize for the late start. Technology is great. So the three talks that we have are the first is Bianca Jimenez is going to talk about what COVID-19 taught us about making more responsible technology. Then we'll proceed with Emad Ehsan talking about building TensorFlow models to estimate climate change. And finally, we'll finish off with Emir Munoz talking about enhancing customer experience with AI ML. So, without further delay, I'll bring Bianca on, introduce her again because it's very interesting stuff in your bio. Okay, I'll try to read faster, and
No
then let
issues,
you go.
Jonna. Take your time.
Okay, now you're good at talking fast, right? You can totally like take 10 minutes. Oh, no, I'm joking. I'll just go
No.
for this and okay, sorry. So, Bianca was recognized by Google developers in 2021 as one of 21 women around the world who are technology trailblazers. She is head of artificial intelligence at UPE and responsible for Gaia, an AI that helps hiring millions of people in Latin America. She is also a Google developer expert in machine learning and a doctoral student in computer science at UFPE. Her work and research address the development of responsible ML systems. Bianca has mentored over 150 startups. Where do you find the time? That's amazing. And given talks to over 10,000 people and published research in international journals and conferences. That's it. I'd like to talk to you, but I'm taking away from the talk, so I'll let you go. You are muted. You're yeah. It's
Sorry,
right.
you can shoot me an email later. It would be
Good.
nice to chat, Jonna.
Great. Looking. I will. Thank you very much for the offer, and I'll let you start now. Okay.
Okay,
Thank you for speaking here.
thanks. Hi, everyone. We had a little bit of technology issues. The other room wasn't working, but I'm happy I'm here right now. So, without further ado, let's just get right on ahead. Um, the first thing I want you to see today, I want you to know actually, is that this is not really an ML talk. It's a talk about technology and everything. Machine learning, maybe a little bit more than the other things, but not only. So just hold my hand and keep connected. So let's keep going. The first thing I would like to ask you today um, is this is an actual plot for Google Trends in and I've searched for fact check. Do you have an idea of what happened in 2016 that made fact check peak on Google Trends on Google search? Do you remember anything that would have people like running to Google and ask to fact check stuff and understand what was going on? If you don't remember, this was exactly the time of the Cambridge Analytica scandal, where people were talking about manipulation of elections in the United States and things like that. And unfortunately, right after this happened, um, things decreased again, and they only peaked again in the end, actually in the beginning of 2020, when we started the vaccine controversy discussions. It's not quite the same as the as it was in 2016 for Cambridge Analytica, but it also had a lot of new searches to try and figure out what was going on. But apart from those two like more relevant moments in our recent history in the past 6 years or so, people don't usually fact check. This is something that happens is happening more and more in a way because agencies, they're regarded, fact checking agencies, they're regarded as the new um, institution of democracy nowadays. But people like lay people like me and you, we don't usually fact check things we read and things we pass on. So um, there is this really nice video with John Oliver about misinformation, where he's talking about everything of about fake news that happened in the elections for the past times in the elections about COVID and the vaccines and all types of treatments and what should you do and flat earth theories and everything like that. And one thing now, I'm from Brazil, so one thing that he says that is really close to me is that is the impact that WhatsApp, it's a messaging app. If you don't have it, if you don't know it, is a Facebook messaging app. It skewed a lot of Brazilian presidential elections in 2018, and people usually use the internet as their main way to communicate nowadays. But a broadband connection in Brazil, they can cost up to 15% of a household's income when people earn a minimum salary. So it's something very hard to have, and they rely on public networks, which aren't all that common. So essentially, people here they can't really go online. It's not trivial, and when they do go online, they don't have a lot of time to fact check too. But this is not like something specific from Brazil. Maybe in the UK that this is not that common, but this is common for most people around the world. So, what we have to remember all the time is that we build products and technology for those people, people who cannot afford broadband, and sometimes they don't even know that they should be fact checking or they shouldn't be taking these information at face value, how they get it. They often, therefore, cannot or do not know that they should fact check. So, well, we can solve this problem with cutting edge technology, right? Like, that's what we do, that's how we work in tech. We apply more technologies to the problems we have today. And if we think about that and we see the academic production for the past few years, if we go on Google Scholar and search for machine learning and fake news detection, you're going to see the number of articles has risen dramatically. People are doing more and more of these systems that automatically check what it is that we're doing, what it is that people are saying, if it's true or if it's myth. And yeah, but this is not the best thing to do, and you can check out that resource later. But usually, what the Reuters Institute says, and it's even research made by the Oxford University in the UK, is that people who work checking facts frequently, they tend to not trust automated solutions because they are prone to errors. Um, and a single mistake can seriously impact the reputation of these institutions because that's what they're supposed to do. They're supposed to be able to accurately say if something is true or not. So humans do not want to um, open like this responsibility and pass it on to AI or ML. And yeah, machine learning models get things wrong. And this is something that we have to understand as developers. We have to know that this is coming, this is going to happen, right? And some quick reasons for such limitations, if you're not really aware of that, or if you're not in the machine learning area, is that every data set is incomplete. Like we do not have perfect data and data sets in the world. They are impossible to gather. I'm going to talk a little bit more about that. But the other thing is that complex phenomena always have attached risk. So we're always working with probabilities. And the third thing is that model results rarely are explained. So let's think a little bit more about the incomplete data. It offers a limited perspective of reality, right? And it has cognitive biases. I apologize for the typo. If they are left untreated and they are perpetuated. So people will often say that they do not have biases and that everything's fine. So I want to make a little experiment with you today. So let's just think of a banana. Think of a banana. The first thing that comes to your head, and Hold it there, right? I think you've already thought of it. So, it's- does it look like one of these? Does your banana look like one of those two pictures, like a green banana or brown banana? Usually it doesn't, right? Maybe you're someone very special and you do things very differently, but bananas are usually thought of as yellow. Usually we say a green banana or a brown banana, but we don't say a yellow banana because it's implicit. And this is a type of bias that we're not aware we have, but we do. Now imagine that you're training a search model for images and you feed images that are most common to you of bananas. You're going to take pictures of bananas and feed it there. You're going to probably feed a lot more of information or everything um, exclusively of yellow bananas, and you won't even give a second thought about it. But if you go on Google now and you search for banana, like the majority of the first results will be yellow bananas. So yeah, this is just like a quick example of what I a quick example we can do in 20 minutes of talk about cognitive biases that we're not aware of. Biases, they're not inherently harmful. They're just a way that we have as humans to process information faster. Because if we are to make decisions all the time concerning everything we're doing, we would never like get up in the morning and get off of bed because there are so many things to consider. So we just simplify a lot of things as a way that our brains found to make processes easier. But we have to be aware that this happens, so that is addressed in our models. The other thing is complex phenomena. Like machine learning models, usually um, they are applied to very complex things. We don't use it to do something that is deterministic. And models, they are by definition a simplification of reality. We try to grasp like the most important concepts and put it in a model to try to approximate results in the complex real world with all the things that are going on. I don't know if you've taken physics in high school, but it's pretty common when you're studying physics that the teachers will tell you not to consider like traction on the rope or not to consider air resistance when you're making some calculations because they're simplifying where you're using a simplified model of reality, right? So this is what machine learning models do. They might end up then ignoring important characteristics. They often lack context. Usually they lack context because I mean, if we see a banana, we know that it can be yellow or green or brown and it's still a banana. And if I paint it blue, it will still be a banana. But this is only possible because you have a lot of other things in your life that allows you to understand that. And when you think of a banana, you have a lot of other information that is related to that, like where it comes from or where it's planted, what can you make with it, like recipes and things like that. And I don't know, a lot of other things like social dimensions, political dimensions, historical dimensions that AI and machine learning models do not have. And the other things that they do not offer deterministic solutions. So one example I bring, I don't know if you've seen it, The Queen's Gambit is a very good series, very short. You should see it if you haven't. But there's this one quote from Beth Harmon I like a lot. She's talking about chess, and she says, it's an entire world of just 64 squares. I feel safe in it. I can control it. I can dominate it, and it's predictable. And this is exactly what the real world is not. So nowadays, you don't need to do a machine learning model to play chess. You can do it with traditional programming. It will be complicated, but you can do it because the rules are very well defined and the world is very well contained. This is not what happens in machine learning and in the real world. And the final thing that I'd like to bring to your attention and make you think about is that model results rarely are explained. So we don't know what models are considering, and we don't know why they're making some of the decisions they're making. So, for instance, like if you try to open a bank account and you're rejected, you don't really know what you have to do to change um, that result, right? They would have to tell you, wow, you don't have a really cool, a really great credit history. but like, yes, what exactly happened? Usually, you don't know that type of information, and therefore you cannot really change. You cannot really figure out what to do. So this is one, and I'm gonna apologize because it's in Portuguese, like the below. But this is one. This is part of my research, my doctoral research, and I was trying to figure out how frequently people put in practice some things that make AI more ethical. And it's not just about not having biases or not perpetuating biases. It has a lot of dimensions. And one of these dimensions is explainability. So if you think about those three here, they are respectively, I mean, not respectively, like the best practice 13 asks how often people use secondary models, simplified secondary models of explainability, like using a decision tree to offer some explainability, some insight as to what a deep learning model, which is more complex, is doing. Number 14 is to use specific techniques for explainability, like LIME or SHAP or orthogonal transformations and things like that. And it's only 50% of people who do that. And usually the people who do one do also the other one. So it's not like some prefer, like half of people prefer doing secondary models and the other half prefers using specific techniques. No, usually it's the same people who practice both. Um, and the last thing is to tell the user how sure the model is about a result. Only 50% of people do that in their daily works and habits. So, yeah, this was a survey ran in Latin America with 135 data scientists, and only 50% of them are really concerned or are able to add these things to their pipelines. And this is something very problematic. And the other thing is that models often lack feedback cycles, which is also something that make them possibly unreliable. But every technology degrades. They tend to lose effectiveness or be very complicated, break, whatever. But machine learning specifically so, and even more, because it reflects a worldview. Is a type of way you're trying to interpret things. It's really a worldview. It's how you see the things as they happen, and this is always changing. Like imagine society for the past 50 years, things that were not as common now are. Like it would be pretty, it's not impossible, but pretty unlikely that I would be here, like as a woman in Brazil, giving you a talk about technology is something that probably would not happen like 50 years ago. And now it does. Um, we have to update these models all the time. And these are major structural changes, but changes can be minor too. And the thing here, I'm just gonna skip over that because of time. But so what to do now that machine learning won't save us, right? Like it has all these problems. Like what can we do about it? Well, it can save us, but not by itself. And that's what I really want to talk about. So let's do it together, right? We can create mixed systems, which are systems that put the humans in the loop and they rely on humans and the AI to work together and reach better results. And why are these solutions better, right? The first thing is that they reduce like fake news damage. I'm going to bring it specifically to the COVID context. They are hard coded, they do not rely solely on machine learning. They are a combined solution and they promote human critical thinking, which is really great because we want to teach humans how to think. We don't want models to, we don't want to outsource thinking. We want to outsource repetitive tasks and things that we're not really capable of considering consistently, things like that. But we want people to think, right? So, how COVID accelerated collaborations between tech areas, right? And this is a combination really of software engineering and UX and UI and all kinds of areas that usually are somewhat disengaged from one another. But the first thing, like the first example I want to bring here is to curate content. You can curate content together. and this is a context in the context of COVID. But this idea, the idea here is to help not to increase algorithmic relevance of fake news. So the objective of social networks is to heighten the engagement of people, right? Maximize this engagement. So if people keep retweeting something that is not accurate, the algorithm will understand that this is really good because this generates engagement, and it will show up with a high priority in your feed. So Twitter implemented the read before you tweet feature. It just asks you to go and read the article before you retweet it. And it seems very simple. It's something hard coded. It's not like very complex. It only checks if the person clicked the link or not. But it ended up yielding more an increase of 40% in open articles and an increase of 33% in clicks and links, even when the nudge did not appear. So people created the habit of checking. Like a third of people created the habit of checking before they retweeted, and they didn't need like something to remind them to do it. And some people, they don't say how many like were the percentage, but they gave up retweeting after reading the complete articles. So this is something great, right? And the idea of these nudges, it's very well documented in social sciences, and it even earned a Nobel in behavior economics. So we can just get these theories and these experiments and apply it to our own apps. The second example is to add a content disclaimer, and I brought here examples from Instagram and Google Translate. So I made an experiment with friends in Instagram. Like I posted a lot of things, and I wanted to see if they received alerts there. And these posts didn't trigger anything. Like when I'm talking about masks, when I'm talking about azithromycin or ivermectin or lockdown, it didn't trigger any type of warning. But when you talk about vaccines in general or tell people to vaccinate, you receive a generic info tip about vaccine information telling you to visit the COVID-19 Information Center for vaccine resources, right? Another thing that happens, another info tip that appears is an info tip against suspicious treatments. And it disregards the quality of content. So probably it has nothing to do with machine learning. It's just like machine learning working together with simple software engineer is probably a reject list and with some trigger words. But anytime that hydroxychloroquine appears or chloroquine appears, it gives off an info tip saying that unapproved treatments may cause serious harm. And you can see that this is from Nature, which is is a very relevant journal. And it's not saying to use it, it's saying exactly the opposite. But still, like it does not regard quality of content. It just says, well, this is a reject list word, so let's just put the warning here to make people think about it. The other thing is when I vaccinated, I had side effects, but I was just saying that after 28 hours, I'm great. Yeah, and then it it covered like what I wrote, and the with an info tip on vaccine safety and effectiveness, and it put the source of the World Health Organization. The trigger here was that I used efeitos adversos, which means side effects. The info tip, they persist, and even in official verified government accounts. So the California account, the Recife account, which is the city I live in. So even though they're saying like accurate factual information, it will still set off the info tip because it's not bringing the info tip up is not an issue, but maybe spreading fake news. This might be fake news, and if you spread it, then it will be harmful. So it has no harm in not really regarding the quality of content, but kind of asking you to check it out. Also, Google Translate brings a disclaimer on content translation with sensitive terms. So I did the same talk in DevFest Brazil 2021. And to translate the abstracts, I used Google Translate. And it gave me a little disclaimer underneath here, like coronavirus disease, and like go and check official sources, right? The third thing is to prioritize trustworthy information by fixing results. And that's what Google search did and still doing throughout the COVID pandemic. If you look for a coronavirus, it will give you like specific things that are fixed there, and they do not rely on um, results brought by machine learning only. Like the top stories, they will be ranked by an algorithm, but there are things that are fixed there and will constantly appear like on the top, like statistics or symptoms, list of symptoms on how do you prevent it, and it's always going to be there, and it does not rely on machine learning algorithmic results to bring quality information. And the fourth thing is to give the choice back to humans. So examples from Instagram and Twitter, and this is the final example we have for today. But for instance, like Donald Trump is tweeting a lot of things, was tweeting a lot of things that are not true, and the information was blocked with an alert, but the records were kept. So it gives you back the control. If you want to see it, you can see it. So it preserves your autonomy, but it tells you that this is not reliable information. Another thing, like the same thing that is pretty much the same thing that Instagram does too. So if you try to look for something like a hashtag on vaccination on Instagram, it will tell you that you should go to like a trustworthy portal of information. You should not be getting information about that from Instagram, but it keeps your autonomy to see results, because you can either go to the website they're telling you to go, and in my case, it sends me to the Brazilian government website, or you ask to see posts anyway, and you can still do it. It does the same for depression, suicide. If you think like if you look for something, some very sensitive terms, it will offer you support. You can talk to a friend, you can talk to a helpline volunteer, you can find ways to support yourself and read a bit more. But you can see the results, but it will first offer to help you and send you to a better way, like to a better result. And yeah, so everything contributes to or undermines our ML models and the AIs we build. So we have to consider machine learning if we're trying to make quality results, if we're trying to stop fake news or minimize fake news, or if we're trying to make the world a better place to navigate with machine learning models, we have to understand that everything is part of our model, because that's how we gather data, that's how we affect people's lives. So we have to think about it more holistically and include software engineering, UX, and every other discipline, social sciences, and everything else. And the communication is key. So it's key between devs and users, between areas, and between people. So yeah, thank you very much for being here today, tonight, no, this afternoon, right, for you. And I hope you're safe. And if you haven't vaccinated, go and vaccinate, because if there's something that is true, is that vaccines work and help save lives. And I hope you all are living and well, so we can meet again at the end of the year in DevFest 2022. Thank you.
Thank you very much, Bianca. That was great. I like that it was nice and positive as well, that there's practices in place, because
Yes.
when it starts off with the fact checking and misinformation, that has really over the past few years, it has been a really big kind of problem, and I find it's kind of difficult as a person, to there's so much
Yes.
information thrown at you, and I'm happy you had John Oliver in, because he is my fact checking, which is
Yes.
not great, but
Yeah.
it's
I
better than
mean,
nothing.
we can do better in a lot of ways, but at least we're doing something, and that makes me feel like better at night. Like I sleep better
Yeah,
knowing that we can do those things, like to improve the world and to make things better for all of us.
yeah, that's very good. Yeah, I was also hope your friends experiment was okay. All that, I don't know what sort of information you fed them at that point. I hope they're still your friends. That's all.
Yes, they are. I told all of them about that. I was like, I put in the stories. I'm doing an experiment. I want to add your picture to my presentation. Is that all right? I asked for consent,
Good. Okay. Good.
so we're doing it
I,
very ethically.
very good. Okay. I'm happy to hear that. I was worried. And just a final point, I want to say that it's um, it's good that the tech companies are doing things to try stop this spread of misinformation or try to encourage fact checking, because I think regulation kind of has to is sometimes finding it hard to keep up. So it, it it's good that there's an own effort on that side. But yeah, yeah.
Yes.
Thank you very much. Thank you very much for speaking here. Okay.
Thanks for the invitation.
Thank
Talk
you.
soon.
Okay.
Bye.
Bye. So now I will introduce our second speaker for this for this part of the session. Hello, Ahmad.
Hello,
How are you today?
I'm doing good. I've been listening to some of the talks, and people, especially these machine learning engineers and data scientists, are doing amazing work. And I am doing good. Thank you for having
Good.
me.
Good. I will introduce you. If it's okay.
Sure.
If I can go ahead. So Ahmad is the youngest Google developer expert from Pakistan. He is Chief Technology Officer at Travelos, a travel journal and video making app for travelers. He has been a top trending GitHub developer and contributes regularly to open source. He has spoken at tech conferences in UK, Denmark, US, Pakistan, and Malaysia. Um, that's I know some people will be interested in the travel journal app, but I'll,
Then make sure to share with them.
oh,
Travis
I
is
will.
the name. Thank you.
uh, so thank you for joining us. I'll give it over to you. Yeah.
Sure. Okay, so I am Imad Hassan. I am a Google developer expert for Pakistan, as well as I am a co-founder of Traverse. And today's talk's topic is Introduction to Climate Change. This is a bit of a detour from the original topic of the talk, that was building TensorFlow models to estimate climate change. Um, by the way, if slides get stuck, which happens sometime in the live stream, please let me know. So this the original title of the talk that I submitted was building TensorFlow models for to estimate climate change. Um, but the thing is that estimating climate change is really simple. The data is already there, hundreds of terabytes, probably petabytes of data that has been collected by European, American, and other Asian research organizations, and there is really no machine learning involved. For example, here is a graph from Harvard in Data, which is a non-profit research organization from Cambridge. And it shows the monthly temperature anomaly by taking the period from 1951 to 1980 as the mean, and using that as the standard. If we see in the last 40 years, the temperature has already moved up by 1 degree Celsius, and this is only considering 1951 to 1980 as the anchor point. If we move that to even further back in 20th century, then we will see even more increase in that in temperature values. That's because human this industrial revolution has been going on for more than 200 years, and we have been pumping um, poisonous gases and a lot of other stuff into the atmosphere. So that was so estimating climate change is really simple. But what I found out that getting started with climate data in general is a bit difficult if you are an aspiring data scientist or machine learning engineer and you want to get started with handling climate data and building models around them. um, that is usually a bit difficult because there is not much documentation on the topics, and also the data sets are so huge that they won't fit on your machines, and also the tools and the formats used are very unfamiliar to the general data science community, from the general tools that are used by the community. So no talk about data science can be started without talking about how can we access data. And even though these data sets are going to be large, but we are going to go ahead regardless, and we'll see a few techniques by which we can reduce the data sets and we can start working with them on our own machines. So there are two main organizations that publish climate data, and one is National Oceanic and Atmospheric Administration, which is an American organization, and the second one is the European Center for Mid-Range Weather Forecasts. Both of them publish data every few hours, and that is made available and free, that you can download. And all the news channels and all the weather forecast apps that you use are in one way or another using data that is made available by these two organizations. There are some other organizations as well, but their weather forecasts are usually not so accurate. So getting started, so we'll be using ECMWF datasets and their libraries, because their datasets have recently proven to outperform the American organization NOAA's weather forecasts. Um, so they have been more accurate. And if you want to get started really quick, you can install Climate Lab, which is a fun library by ECMWF. It has very few methods, but it does a lot in the background. And you can call the load source method and load your climate data file. But let's dive deep into what these data formats are. For example, we have test.grib listed here. So the data formats for climate data are usually gridded data. For example, if the data corresponds to the sensor readings around the Earth, or the satellite data that is related to weather or some other observation. And the gridded data simply means that each data point is mapped to some coordinate, which can be both spatial or temporal. So for example, if we have a data set with temperature values, that data set, so all the entries in that file would correspond to a certain physical place which has some longitude and latitude on Earth, and some time for which that data corresponds to. So for example, for 29th of January, temperature for the coordinates of Lahore. And if you were to visualize such data, you can do so because very easily with these libraries, because these all the data points are corresponding to some longitude or latitude. So for example, here we have the wind speed, and that is plotted with the color. The color in the background shows the speed of the wind, the intensity. So this right bar shows around the range in which the wind speed lies, and the direction of the arrows shows at which particular longitude and latitude this particular region has the wind blowing. For example, this here you can see the Great Britain and Ireland, and you can see here sort of a hurricane like wind pattern is forming. This data is from 2011. I'm not a climate scientist, so I'm not sure if that is a hurricane forming or just a normal wind pattern. But we'll see how to make sense bit by bit. So the data formats that are used for storing and transmitting these climate data sets are netcdf and grib, which is short for gridded binary. The second one, grib, is the format recommended by ECMWF, and it is the one that was originally devised by World Meteorological Organization, and it is much more efficient than netcdf, but uh, setting up the system libraries for manipulating grib files on your machine could be cumbersome. So if you are able to get started with netcdf, that is fine as well. And these are the necessary libraries that we'll be going to look at while we build an example climate project. So CDS API is a Python library that is made available by ECMWF, and they have a service called Kubernetes Data Store, CDS for short, which makes available those weather forecasts that they are generating to the public. So a programmer can easily use CDS API library to access those data files. And then we have Xarray, which is a library for manipulating these data formats. We'll see example of this. And cfgrib is the engine used for that helps Xarray in reading grib files. Then for plotting and maps, we have Shapely, Cartopy, and Matplotlib, which will help us with plotting these temperature maps on the actual map of the world. So since this is because of the shortage of time, I'm not going to show you live demo, but we'll walk through some code. And CDS, once you have installed CDS API for Python, you can simply call include the client and call the retrieve method. And you first you have to specify the data set for which you are going to take your monthly average values. So for example, here, if you go to cds.climate.copernicus.eu, you will have this whole list of data sets that are available that you can download. So here we'll be using the monthly mean data set. But while downloading this, their dashboard helps you through selecting which data variables you want to include for which dates. But make sure you do not include a lot of data, because you will have to wait in the queue and your data will be downloaded really slow if you request a lot of data at once. So anyways, here we are downloading monthly mean temperatures, and the variables that we are specifying are 2 meter temperature. So this is the variable that is listed by them inside the dataset. Once you select a dataset, for example, if we go to this dataset and go to download data section, we can see the variables section there. So this particular dataset has only this variable, but this one has surface air temperature, surface air relative humidity, and 0 to 7 centimeter volumetric soil moisture. So we can specify the variables we want to download, the range of the years, month, and in this case, time is going to be the midnight, because we are downloading monthly means, so time is not very relevant, and the name of the local file where it will be downloaded. And once we include our downloaded data file, so I have a bit different name for the local file that I downloaded, and we can simply call xarray.openDataset method, and we specify the engine, which is going to be cfgrib, to include our dataset. And here is how the dataset summary would be printed for you in your notebook or on your console once you print your data set. And here you can see you have dimensions, coordinates, your variable. This is the data 2-meter temperature that we asked for, and this is some metadata information. Let's look at dimension. So dimension is like you have dimensions for your arrays or lists in Python. So you have 2D arrays or 3D lists or arrays, and this is since and the coordinates, you can think of them as named dimensions. So instead of using scare brackets to access the data at certain index, call you give the name of the coordinate and you specify the value of that coordinate at which you want your data variable value. So Xarray is, since it is for manipulating gridded data, so that's why we have coordinates as sort of named dimensions built into our data set. And this would be our dataset summary. And Xarray has provided us with a lot of cool features. For example, here our goal is to plot the annual mean temperature for year 2020 on the map of the Earth. So let's see how we are going to achieve that. Since in our original data set, you can see in the time dimension, we have every month's temperature values. So from those monthly values, we are going to calculate the annual mean values. And for that, we are first going to group by our dataset on the time dimension or time coordinate. And here you can see we can specify the year, which is in the subdimension of time, sort of. So time dot year and dot mean, and it will calculate the mean for all the years. And once we print that, you can see now instead of time, we have year as our dimension. And here you can see as well, we have 43 years. And here we had 515 months in the time. And so let's get here. 43 years, starting from 1979 to ending in 2021. And from that those annual mean values, let's select the year 2020. And this is, so here you can see we do not have any dimension value other than, so year has disappeared from dimension value because there is only 1 year's related data in this. And in the coordinates, it does appear, but it has only single value. But we have a lot of longitude and latitude values, and the temperature value, T2M, is now the annual mean of those temperatures, those monthly temperatures. So now we are going to plot that temperature on a map for which we'll be using Cartopy. And this is a very cool library. And but in order for Xarray to plot your dataset, it first needs to be converted into an array. And tar is a dataset array, Xarray dataset data array, and you can call the plot method on it. And here we are specifying we want orthographic projection, which is going to plot a circular globe, sort of a spherical shape, but in 2D. And this is our base transformation. So usually all the climate datasets are in plate curry, which is a normal projection. Usually this is the standard dataset format. And here we are specifying set it to globe, also plot the coastlines. And this is how the temperature graph, temperature map looks like for average temperature map for the year 2020. But these values are in Kelvin because that's what scientists use. And here you can see the whole range, but it doesn't give the idea about what is the freezing point of water and what temperature is above or what's below that. So let's convert this into Kelvin. And just like NumPy, we have this cool projection. This is also called projection, and this feature in X-array where you can subtract a single variable from the whole array, a single scalar integer from the whole array, and we convert it to Celsius and the rest, and we also change the projection to plate curry in this case to see how that looks like. And this is the temperature map in Celsius for this is the mean temperature of the year 2020. It gives a summary of how the temperature is usually around the world, and all the values that are white are at freezing point, and the ones towards blue will be below freezing, and the ones towards a reddish color will be above freezing point. And this is how you build a temperature map. So let's see if we can go on to tackle some bigger um, workloads. So for example, if you were to download the hourly temperature for the year 2020, so this is going to download all the hourly temperature, which are going to be hundreds of thousands of values for every coordinate on Earth. So I downloaded this file and it took about 10 minutes because there was no queue in CDS API, and the file came out to be 17 GB, and that cannot fit in my machine's memory. So that's where Dask comes to help. Yeah, and Dask is a parallelism. Dask provides very cool parallelism for Python workloads. So here, and Dask is also built in to Xarray, so we don't need to call any extra method. We just specify chunks equals auto method. Auto argument, and Xarray would know that it should create a few chunks of data, and based on the number of cores available on your machine, and then it will work on those cores in parallel instead of just working on the whole dataset at once. This is what makes our computation a lot faster. But with Dask, there's another cool functionality that our normal methods are not executed right away. For example, dataset.max is an Xarray method, which would give us the maximum value of temperature among all the values in our array, in our dataset, which is 17 GB. This is going to take a lot of time, but in the case of Dask, it runs immediately because it doesn't compute it right away. It creates a graph and it stacks all the calls that you have placed. And once you call the .compute method, then it runs all those function calls that you had specified. And if you happen to run these computations on cluster of computers in some cloud or on your local network, in that case, the case Dask magically performs these tasks on those parallels, on those clusters in parallel, and you get your results really fast. So a few examples of the projects that I built using these libraries. I am still in the learning process, I would say, because these are my side projects. One is a climate visualization, climate change visualization, which is at climate.alternate.parts. And if you go here, you can select any year, and it would plot the mean temperature of that year. This is not complete. I'm working on it, but you can also filter by a specific month. And the extreme, you can also visualize the extreme temperatures, the hottest and the coldest temperature for the year. And the other one is the K2 wind map. It is in beta. This is not complete, but it shows it uses the wind data variables from ECMWF, and it plots the winds in the wind around the globe in a very cool fashion if loads in time. Okay, so until then, let's talk about what's happening in the deep learning and machine learning in the climate research. Um, so the climate models. So we talked about NOAA and ECMWF. These are the organizations that are providing us with climate data and forecasts. They use physics laws to compute all the individual climate data variables like temperature, pressure, humidity, wind speed at certain levels of the atmosphere at certain altitude. All of those are computed based on the laws of physics for every coordinate on Earth for every time that it is making prediction for. And these forecasts are usually published from every 2, 3 to 6 hours, and depending on the organization. And the models are give very accurate results for the next few hours, and their accuracy decreases for the next days. Um, but Google recently published a model called MetNet, which is a deep learning based model that instead of using physics laws, it uses the memory mechanism of deep learning. So sequence models like LSTM, your transformers, and some axial attention techniques that I'm also learning. So using those techniques based on the previous behavior of weather data. So let's say if you have certain data variables on Saturday, how the weather turned out to be on the next day after that. So using that mechanism of and that feature of sequence models, your recurrent neural networks and deep learning, it predicts the temperature for the next day's temperature, your state, your weather state, and it has shown to improve. It has shown to give very accurate results, but it is not as good as those state-of-the-art models by those bigger organizations. But it uses way less computational resources. They only used, I think, 5,000 TPUs to train these models, which is a lot for individual independent developers, but still it is way less than those government organizations are using for forecasting weather. And they also came up with MetNet 2 in 2021. Um, they have very cool explanation on the YouTube and Google's AI blog. Make sure to check out. And these are some organizations working in climate change. If you are interested in working with them or contributing to their open source projects on GitHub, if you want to get involved. And that's all from me. If you have any questions or want access to code, you can reach out to me on Twitter as well. And a lot of code from me is on GitHub as well.
Emma, thank you very much. Sorry.
Yeah, the talk is over. I was just seeing if the wind animation has loaded. Then
Oh, thank you very much for the talk. It was a funny follow up to fact checking to actually doing it or implementing you know, the theory that there is no climate change. So it was nice to see your work into actually proving otherwise. Or yeah,
thank you.
it was very good. Oh, what got you interested in climate change other than the impending doom?
So actually, where I am from in Pakistan, my hometown is sort of a desert place. It is a very dry place, and So it is very hot in summer. It's my hometown is Bhakar, and every year it feels hotter and hotter. And I was thinking whether is it placebo effect? Am I reading a lot of news that temperature is rising, or am I actually feeling more heat than the previous year?
Mhm.
So that's why I decided to see what exactly is happening. Can we see it tangibly? And when I researched on the internet, I found out that it was really easy to find the data. The data is already there. These organizations have published and made it publicly available, but some people just don't want to look.
Yeah,
And yeah,
you should do a workshop with us someday on this as well.
sure,
Different
sure.
event.
That would be that would be my pleasure.
Great. Thank you very much. Enjoy the rest of your day.
Thank
And
you,
thank you very much for
Jana.
joining us today.
Sure. Thank you for
Thank
having
you.
me. Take care.
Yep. Bye bye.
Bye.
Okay. So I will introduce our last speaker of the evening. I'm very happy to introduce our last speaker of the day. Still, so we have next up we have Emir Munoz, and he'll be talking about enhancing customer experience with AI ML. Sorry, Emir. Now you're
Hey,
now we
can you
see
hear me
you.
now?
I can hear
Yes,
you. How are you?
I'm good, good, and you?
Good. Not too bad. How is Ireland? Is it?
It's fine there, definitely. We got some sun. See.
London is okay as well. It's nice. We're inside all day. But
Oh, yeah.
it's nice here. I will introduce you if that's if I can go ahead. So Amir is a team lead, lead machine learning engineer at Genesis and the Digital and AI Group based in Galway, Ireland. His focus is to find innovative applications of machine learning and help build services for the next generation customer experience. Emma received a bachelor's in engineering and MSc in computer engineering from Universidad de Santiago, Chile, and holds a PhD in computer science from the National University of Ireland in Galway. Um, there, I'll.
That sounds great.
Are you ready for the talk? I'm very much
Let, let,
looking forward to it.
let's see.
Uh,
Thanks a lot.
okay, there. Your slides are up. I'll disappear. I'll be back here
Uh,
again after. Thank you.
Thanks a lot, yeah. Okay, thanks a lot, and thanks for making it until the end. So I will speak a little bit about today about the customer experience and what we do in Genesis to around this. So let me tell you start with the story, right? So before I joined Genesis, a little did I know about customer centers or call centers, right? How they depend on the channel that you are contacting them, voice, emails, messages. Now many applications have messages like Twitter, Facebook, right? Or Instagram. So many companies are opening different channels for you to reach out to them. And so this is part of the customer experience, right? So this is like something that each one of us has passing through. Each one of us like probably speaks to call centers every month. It depends on the cases. And I want to give you today a little bit of an insider view about this and what we are doing in that sense. So Genesis, just to give you some context, is it's one of the leaders in terms of like customer experience, and it has many different solutions. We have onboard customers which are like some of the big telcos around the world, right? Many partners around call centers. You will be amazed of how many partners we have. So how many tools or systems, people trying to do additional things on top of like the infra that Genesis is providing. Uh, all this, of course, generates a lot of data. So there are each interaction, each time that you call into a call center, that generates quite a bit of data. And it's all stored in some databases, right, or systems, and help us later to do some analysis or training to agents to improve even further that the experience that the people will have. And that's, of course, it's not only tied to any country, it's all around the world. And we are trying to push a lot into the use of AI and ML into services to help the experience. So Genesis has been championing like experience as service, not only right like not only to be able to contact people to talk to an agent or to I don't know, complain or to ask questions to companies, but have a good experience, and that comes from people from this, as I mentioned before, from multiple channels. So now I could be browsing on the web, right, checking some products. I could be then writing an email because I have an additional question. I could get answers maybe via WhatsApp and things like that. So all that interconnection, it's sort of like part of the engagement that I'm having as a user with a brand. So I'm users for us are in the middle of all this, right? And companies are trying to keep us happy. So then looking for loyalty, empathy, and trust. Right? So that's part of this communication or interaction that we are doing. And everything is about the experience that we have. And companies want to do as much as possible a personalized experience. So companies will know, right? Your name will try to know which sort of like preference you want. Do you want to receive calls, or you just want to receive emails, or you want to be receive messages to Twitter, and so on. So there are pillars around that, which are around, I guess, as I mentioned, engagement. So we will receive marketing. We usually receive marketing. We try to buy the most as much as possible. That doesn't go into the spam. That will be tied to sales, of course, and to services. There is also the customer and employee data. So in contact centers, like for us, right, providing these services, we don't only look into the end customers, right, but we also look into who is behind that. So the agents who are attending people, attending the calls, attending those messages, and answering the questions from customers. So there will be information about both customers and employees or agents, as I say, historical data for both of them. Agents will get some training. We will have information about that, right? Maybe customers want to, when I say customers, I think about organizations or call centers. They want to integrate the information from third parties, some insight tools that they might have, right? And all that, again, it's towards enriching the experience that we have as users, as end users. As I mentioned, there's a lot of data around here, and we are trying to push further the use of or application of artificial intelligence and machine learning. So we're trying to look into how can we improve conversations, how can we automate some of the processes, right? Like again, some people maybe don't like to speak to agents, right? Or sometimes you need to speak to many agents to be solving your case. So we want to avoid that and improve the experience by automation and some optimizations as well that could be possible. So, as I mentioned before, like empathy is one of the main sort of concepts and aims of many organizations. So to reach this sort of empathy, right? So we reach a sort of like a good understanding between customers, or brands make a good understanding about the customers. You have 4 steps that we are trying to propose. It's the first one is to listen, right? So the experience that you have with the brands and what impact that those brands make into you. So they want to know who is the user, right? What how they get here, how did they hear about the brands, and all that information was via a campaign by email, or was a campaign by phone calls, and so on. Then after once that you're collecting the data, you try to understand and trying to start making some predictions. So these predictions could be, again, how are you feeling? What sort of intent? Why do you come here? Right? What are you expecting to achieve in this case? If I'm making a call to, I don't know, to switch my internet provider, right? Then the person, the intent is like, so I want to switch my provider, right? And then the person will try to offer you maybe some plans or present you the different alternatives that you might have. That's also involves recommendations. But the next step that we hope is the act. So we need to act in the moment of trust and empower resources to achieve that outcome. So what do they want? As I mentioned before, that comes a little bit part of the intent that we captured before. Try to make those predictions, and depending how far you go into this conversation, then you start getting more and more information. So once the person, the customer, I want to to call into contact center, I'm providing much more information so the agent on the other side knows what are the steps to follow. So that's the act part. And then learn based on what I did or how we did since today, right? We can learn what was the outcome that we achieved. Maybe I didn't want any of the plans because none of them suit me, and then I'm quitting and I'm closing my account with that company, right? So that could be an outcome which is a bad outcome for them, but they can learn from that process and they can try to look how to improve things. So all these things, as I mentioned, they could be, all these interactions could be through omni-channels, so different channels that companies are now activating to or opening for customers to contact them. As I mentioned, you could be a phone call, could be your open a website where you're browsing through a website, you're filling forms, could be some mobile applications, could be emails, could be text messages. So there are now many channels to start interacting with the brands or organizations. So all this as well needs to be somehow integrated, so they know that my phone number is this one, and right, my email is that one, so they can identify that I am the same person. So all that is sort of like tied together and trying to create, as I mentioned you before, sort of like this empathy framework that we could put in practice. On the other side, as I said before, there are the agents, right? So agents, as soon as I'm calling into a call center, the agent needs to have some context about why I'm calling, who I am, right? If I'm a customer or I'm not a customer. If I am a customer, maybe I want to be called by my name. I want them to have the historical information about or previous times or previous issues that I had with them, right? If I'm a new customer, then the interaction will be different. So all that part will be into the employee side in the call centers. And we have sort of like this layer of or framework which is around artificial intelligence. So as I mentioned before, we have lot of information, lot of data, right? That it's coming not only from interaction, from events inside the platform of Genesis, but we also have some coming from Adobe experience, right? So Microsoft, Salesforce, if you have some issues in ServiceNow, Zendesk, and of course as well, Google is part of that. So I want to go now dive deeper into the AI part, right? That's like the relevant for this session. So into the AI part of the AI portfolio that Genesis at the moment it's providing, we try to have something for all the sites, right? For end users, for the organizations themselves, and as well for the agents. So predictive engagement, it's one of them, which is try to capture information about the engagement that customers have with some brands in real time. So how this is done is sort of like Google, the Google tracking, that you have some snippets that go into your website, and then all the actions, which websites customers are accessing or what they're doing, that will be tracked into some series of events. So you can keep track in the background of a session that customers have with a website. So you can say, oh, this customer was here, started with the login page, right? Then went maybe to check the balance or was browsing some products, and then went to the shopping cart and made the payment. So all that is the session of customers that we can help and we can learn from them. In terms of interaction as well, chatbots are pretty relevant. Voice bots if you are making calls. So all that's about, again, how to automate the process of customers interacting with brands. Sometimes like I just want to know something very simple, like I know what time the store is open. So maybe I don't need to call the to the company, but maybe I just need to go and interact with a chatbot, and the chatbot can easily answer my data based on some knowledge base in the background. Once that I reach the point, so where I'm interacting with somebody on the other side, so the chatbot maybe cannot answer my problem, it's too complex to be answered by a chatbot, then I interact with a real person. So in that interaction, we tried as well to capture, back into the intent, we try to capture what is the intent of the customer, right? What is the customer trying to achieve? And based on that, we can go and maybe try to find the best agent to answer those questions or to help with the problems that the customers may have. And that's part of this predictive routing also tool. That it's the one that I work most, so I will go deeper into that and show you the inside part of the machine learning that we are doing. And the last one is agent assist. So this goes around into recommendations, coaching, and search. So basically, again, if you are calling, maybe you have issues with your computer, you are calling to the technical support. So the technical support, they need to have all the manuals about all the laptops or all the versions, right? All the models that they might have in, and they need to access them or doing them one by memory, by heart, or they can have a knowledge base where they can easily search and say, okay, this is your model, then this is the issue, yeah, right? So it's like change this or do that, and the devices will be working again. So that sort of information can be also provided and help agents, I can say, to facilitate interaction with customers and to solve issues quickly. So in all this, there's quite a bit of optimization that I will also describe later in the talk. So I will dive a little bit deeper into what I mentioned before, this predictive engagement. So as I mentioned, this tries to capture events that customers make in some of the websites. Again, it depends on which pages you are visiting, right? What actions are you doing? Are you clicking certain buttons? Are you filling forms, right? So that could help the companies trying to identify, for example, if you're struggling trying to fill a form. There will be some signals, like, for example, you are taking more than half an hour in a form, or you're going for the form page to some FAQ page, and that could maybe trigger an action. So there could be some actions that it could be triggered, like fire a chatbot or offer somebody to help you in the process. And that's very important, again, in some of the use cases, like, let's say, mortgages, where it's a long process that you have to follow, and you have to fill many forms and submit many documents. So that could be as well helping you into that. We have as well the chatbots and voice bots, as I said before. You have two layers, the self-service, right, digital, which is like you send emails or messages, and then there could be some chatbots that you can interact. Or if you are calling into a call center, you can have the voice call bots, right? And all that, again, it's towards improving the experience of customers, and that will make use of any data that organizations know about their customers. Predictive routing. Predictive routing, as I mentioned, there are several stages, and maybe I will show as well later more in detail. So there are several stages, like since you're calling into, you dial the number, right? Your call will go into some machine that will try to connect you with some of the users. So there is something called the interaction voice recognition or interaction voice routing that will try to identify, right, based on you press number one, you press number two, all those selections that you're making in the phone will try to identify what is your intent and where you should go into the call center. You could also get or extract intents from bots. You could extract topics or sentiment. There are several some of tools that we can use to identify that. As customers, we are sort of like categorized, right? So that's what companies will do. Will be categorized. You will fall into different segments. Will information about you. If you're a recurring customer, when was the last time you contacted, or if you are making purchase, how much purchase have you done into all the time, or if you have a contract, how long has been that contract, and so on. On the agent side, we will know information about what skills this agent has, what certifications maybe we could have as well, or what group the agent belongs, and some of the metrics as well that are particular to call centers that we can track, and where that agent as well may need training or not. And the outcome again, it could be in different shapes. Could be around cost optimization or experience. And that as well will be tracked in the system. So all that is data events that we can we can know, and we can feed them into machine learning for helping the routing of the interactions. So as mentioned, going deeper into the predictive routing. So you call into a call center, right? So if you are a known customer, then we will know, or companies will know, you having your previous interactions, right? Some information about you, what products or plans you might have with them. And then based on that information, they will try to find the best agent that could help you to solve the case. You will go interact with the agent, speak, right? And then at the end, you will get this outcome or result that, again, as I mentioned, could be your customer feedback. So you could say, oh, yeah, I like the interaction, so I'm satisfied with this interaction. We have information as well in terms of like how long was this call, right? Or did this agent really help you with the problem, or you might be calling again because the problem is still not solved. And if there were some sales involved, you will know if, for example, you close your contract or if you purchase something, right? Things like that. And all that comes as a feedback into the machine learning part that will help us to, with the label data at the end, it could help us to improve the models. So let me go deeper into what exactly it's a conversation in a customer center, right? So in a conversation, again, for us, it's like it looks like you call, you start listening some music sometimes, right? And you press one, there's a menu with options that you need to select, and according to that, you will speak to an agent. So there are a couple of components in there. As I mentioned, IVR is one of them, and then comes this the distributor part, which is basically identify, okay, based on your selections, you need to go into this queue. So queue is basically a virtual structure that will try to put all the calls or interactions in a given order to be routed to agents. From there, from all this, we can extract timestamps, and those timestamps will provide us some metrics at the end of the interactions. So why are we doing all this, right? So there are a couple of business cases that we have involved, right? So you could say, okay, you want to improve agent productivity, right? So you want to increase efficiency of agents or help agents to start delivering fast calls to customers. You can improve customer satisfaction. So that's one of the main ones and goal of many organizations, which is like you want to make them happy, solve their cases. You also may want to increase revenue, right? Trying to help customer agents trying to help agents get information about the sales, the products that they are selling, or trying to help them to make the sales, or trying to avoid sometimes customers leaving a given service. And you can, of course, go into trying to lower the costs, trying to have a better utilization of the agents, and trying to shorten the handle times or the time that agents spend talking to customers. So again, all these sort of like benefits, they are measured through some KPIs that we identify. And those KPIs are the ones which are become the goals of these models that we use in the background to route the calls. And among them, again, you have average handle time, number of transfers. People don't like to be transferred, right? I want one agent to be able to solve my case. You have case resolution time, the one I mentioned, customer satisfaction, or net promoter score. Like I like this brand and I want to recommend them, or first call resolution. So this company basically, or this agent solved my case and I don't need to be calling again. And sales and revenue or churn, which are related with costs. So digging deeper into the machine learning. So quickly, we go into the machine learning. We have the MLOps pipeline. We have more requirements, data collection and cleansing, data analysis. So most of that is done as part of like the R&D or part of like data science team. And then we deliver features. So those features will be put into production. We have a feature store to do that. And those then there will be used into the automation of model training. And then we have the model evaluation part, model deployment, so for the serving inference part, and model monitoring. So that will help us to identify if there are any issues with the models, and we can, let's say, trigger the model retraining or do some changes into the features that we are feeding into the models. So based on what I said before, what happens basically when you call into a call center, you enter into this queue, right? So we identify which agents are on the other side available for you to talk. And then as an assignment service, we just identify a score, right? So we'll pass this information. I have these agents available, and then that will come into predictive routing. Predictive routing, as I mentioned before, we have the feature stores, and in there we will contain information or features or profiles about agents, customers, and then also those ones will be passed into model serving tool that it will have contain some models. So those models, as I mentioned, they are based on KPIs or things that you want to optimize. Some of them will be maximization, some of them will be minimization, some of them will be classification, some of them will be regression. So it depends on the business, in this case, the business scenario. And predictive routing, what we'll do, it will try to say, okay, from the agents that you have available, these are the predictions, or these are the rankings that I could give to them. So the ones, the first one should be the best one to take this call. If it's not available, then you move into a second and start and so on. So that will try, and then you are connected into an agent. So all that happens before you speak with somebody in a call center. So in our case, like we want to make this, so you see that this is like, again, very machine learning part, and we try to make that very easy to digest to customers, right? So our customers, which are the call center admins, right? So they don't need to know about models. They don't need to know about assignment. They don't need to know about those rules or feature store. They just need to be able to say, okay, I have this data, or you, as a company, have my data. So what sort of optimizations can I make into my systems? What kind of optimization can I make into my sales queue or into my technical support queue? So there will be, as I mentioned, different KPIs that could be tested. And what we put in place is a simple sort of like a analysis pipeline. So we go and try to identify first like the data set quality. So we have different checks that we apply on top of the data set to identify it's a proper set for doing model training. And then after we train a model, and then we identify, okay, are we getting a good model? Are we getting good evaluation metrics for this model? And all that will be weighted into a final score that we can say, yes, we can go and optimize maybe this KPI, right? And we can have like good potential for some KPIs and low potential for other KPIs. So all that depends on what data we have about the interactions, right? What historical data we have. And we also, after we do this, right, so customers say, okay, you have good potential maybe for optimizing my handle time. Then what we do is basically on the background start running A/B testing. So customers can activate this and can go into A/B testing. A/B testing is just simply to use our solution half of the time, and the other half of the time use something which is called the standard routing. And we do a comparison across a period of time. Usually it will be 2 weeks, 3 weeks, and depend on the flow or volume of interactions. And then we present some results about that. And those results are the ones that customers can use to make the final decision where to activate the solution full time or not. And that optimization will be showing you some benefit. So the benefit unit will be depending on the API that we are trying to optimize. And again, we are trying as well to include this across all the different media types. So we can optimize voice, emails, messages, and more. So just to wrap up in the last part, so experience as a service, it's something growing that to me, it have many, many applications for machine learning. I mentioned just here a few of them, but there are many much more in the background being experimented. The personalization in general for call centers and for companies and brands, it's key to have some personalization of the customers, to provide information in the shape that the customers want to consume it easily. We have, as I mentioned before, so all the interactions, everything that passes to the platform generates a footprint and leaves a footprint that we can start measuring, so we can compute metrics and we can use it for improving the future experience of the customers. And all the systems, those applications that we are building around machine learning, they require some automation because they need to be run at scales for many customers, multiple models per customer. And the final point is like, again, that users, not most of the time, they shouldn't know what the details of machine learning, but they should be able to assess and evaluate when the solution using machine learning is providing them some benefit on when not. So that's sort of like the low code trend that most are talking about. So that's for my presentation. Any questions?
Thank you very much, Emir. Yeah, if anybody has questions, we'll give you a minute to post them. But thank you very much for the talk. I really like how empathy is kind of at the core center of the solutions that Genesis creates. I think it's very important, and kind of it's nice to be working on something, or that you're working on something that improves people's lives with its agents or the callers, because we've all been there and on the end of the phone for ages, and so that's very good. Thank you for being our closing talk on the AI ML track for
No problem.
DevFest UKI in Ireland 2021, and representing Ireland.
Yeah, it was no, I wish I was there, but well, in this situation, it's not the best for me.
Well, next year we'll be in probably in person, then in Galway, hopefully. Well, we'll see. I don't know what the future holds. It'll be positive though. That this is.
Yes,
Look,
exactly.
thank you very much. Enjoy the rest of your day. And thank you for joining us here today, and thank you everyone who was watching as well. It's yeah, it's very nice.
Thanks very much, guys. Take care. Enjoy.
Okay.
Bye-bye.
Bye.